Hey everybody, we're back. Let me turn off the music. I'm listening to Frank Zappa, The Mothers of Invention. If you're stuck at home looking for new music to listen to, check out Frank Zappa, super weird from the 70s. Is this what your room looks like now? From living in it for 2 weeks? That's kind of what my room looks like. Just kidding. Anyways, that's the album, Frank Zappa, Mothers of Invention. That album is called Overnight Sensation. Super weird. Anyways, let's get back to business here. It's time for part 2 of secondary air pollutants. We were talking in the last video about the environmental effects of acid deposition or acid rain. By the way, acid deposition, like depositing these acid acidified, like nitric acid and sulfuric acid, in liquid or dry form onto the earth, like it's deposited. So that's why it's called deposition, acid deposition. It is called acid rain, but there's dry deposition too, which I'll talk about in a moment. It doesn't have to be rain. Okay, so we were here talking about how the acid doesn't like land on you and burn you. Instead, it has other effects, specifically on plants. We said that it removes the leaves' protective waxy layer, which can slow photosynthesis and stunt growth and become more susceptible to diseases in plants. Well, what also happens is it gets into the soil, and this is bad. Okay, and I'll tell you why this is bad. Is because if you remember, more acidic soils or more acidic water, it has more hydrogen ions, right? That H+. So if there's more hydrogen ions in the soil, what happens is, this is kind of complicated. We don't want to get into it now. This is like soil science. But these calcium ions are also positively charged. Potassium is positively charged. Magnesium is positively charged. And these positively charged nutrients are stuck to clay particles and other colloids in the soil. And when more hydrogen ions come in from acid rain, let's say, the hydrogen ions will kind of kick out the calcium and the potassium and the magnesium, and instead will bind to those colloids, bind to that clay. And so what it says here, these plants' nutrients become unavailable because they leach out. The hydrogen ions take over, kick out the calcium and potassium and magnesium in the soil, and those nutrients are leached out of the soil. And so if you don't have these plant nutrients, well, guess what? Your plants are not going to grow correctly. They're going to weaken. They're going to die. Okay, similar thing happens with aluminum. Aluminum is also a positively charged ion, and although it's not a plant nutrient, it has the same process that happens. It gets kicked out of the clay or the other colloids. And so that means aluminum gets carried into the soil, into surface waters, and plants have difficulty absorbing water and nutrients with aluminum in it. Aluminum interferes with cell functions. It screws up the plants, and it reduces their ability to withstand drought and diseases and things like that. So aluminum is not good. And so when you unbind it from the clay particles, it becomes suspended, or it becomes dissolved in the surface waters, and that is taken up by the plants, and it's basically toxic to the plants. All right, hope I explained that okay. Number 3, it says acid deposition can displace heavy metals from soil particles and put them into solution, which can be absorbed into the plants. So it's similar as what I said to aluminum. And then the 4th one says, just because of all of this, think about it, the whole food chain is affected because it starts with the plants, the primary producers. And if your primary producers aren't growing correctly and vigorously and creating a lot of biomass, then everything that eats that is going to be affected. It's a problem, people. All right. So let's go on to the next. I hope this is really good information for how acid deposition affects plants. Now it can also affect aquatic environments. So the acid gets into the water, it lowers the pH of the water, which means, of course, the water becomes more acidic. And that can affect fish eggs from hatching, can prevent fish eggs from hatching, and also enzyme activity can be affected by in the fish. So adult fish may even die. Okay, so the line down here says, remember, even if an organism is not directly affected by acid rain, the ability of that organism to get food, the availability of food can be seriously affected. All right. When I learned this, it was like an aha moment. It was like, oh, okay, that's how it works. It's not like, but it really affects the basic underlying structure of the ecosystem. So fascinating. And then you may have heard how statues and buildings can be affected by acid rain. The reason this happens is because many buildings and statues are made from calcareous rocks. That's rocks that contain calcium carbonate, like marble, limestone, these things. So the acids contained in the acid rain are capable of transforming the calcium carbonate into different salts which are washed away. So here's your chemical formula. You have calcium carbonate, and then you guys remember what this is? This is your acid. That's right, sulfuric acid, calcium carbonate. So the sulfuric acid combines with the calcium carbonate and forms a new, very soluble compound here called calcium sulfite. And so that's the stuff that kind of gets washed away. So you can see George, good old George Washington here in New York City, 1944. And yeah, perfect in 1944, but now at present, he's got some acne. No, folks, that's not acne. That is acid rain coming in and wearing away at George's face by this chemical reaction here. All right, and this is something in Germany, another photograph in Germany. And you can look online and find all kind of different examples of statuary, Roman statues from years and years ago, thousands of years ago, which were fine up until a couple hundred years ago. And now they're being eroded. It's a big problem. Okay, so now you know about that. Just a note here that a nice diagram that shows the power plant with the fossil fuel emissions, sulfur dioxide and the nitrogen oxides getting into the atmosphere and combining, as we saw, with oxygen and with water, and creating either nitric acid or sulfuric acid, and coming down as acid rain. But you can have this stuff dry deposit. Now, what happens here is the dry deposit, the sulfur dioxides and the nitrogen oxides, they get into the atmosphere. They might not combine with water, but they fall down into the soil and into the ocean or the lake. That's where you can get acidification happening. So this is called dry deposition because it doesn't combine with water. Sweet. Let's move on. So we got a list of our primary pollutants, which you learned last lecture on Tuesday. And so this one says, which of the primary pollutants are involved in the formation of ground level ozone? So I'll give you a hint. There's two. So figure this one out. Pause the video if you need to, and I'll come back with the answer. Okay, you got the answer? Did you say nitrogen oxides and volatile organic compounds? Well, if you did, you are correct. So let's move on and see how this works. Use your cards. We know that nitrogen oxides and volatile organic compounds are associated with ground level ozone. They're the primary pollutants. So put a little diagram together like we did in the last video. See if you can put together everything, and I'll show you mine after you've done it. So pause the video And now I'll show you. This is the one that I have. So we have our vehicle emissions, and the vehicle emissions are giving off nitrogen oxides and volatile organic compounds, or NOx and VOx, as we like to say, combining with oxygen in the atmosphere. And this is important. It's got to be in the presence of sunlight. If sunlight is what fuels that, or what essentially does is it breaks apart this oxygen, this oxygen molecule, and creates an oxygen radical, which binds with another oxygen. I would love to describe it on the board, but we don't have a board here. Okay, so that's why you get O3. Ozone is O3, as you remember. Okay, so we don't have a specific chemical formula. It's actually complicated. We're not going to get into it all. Just know that these are your reactants, and this is your product here, and needs to be in the presence of sunlight. All right, so that's ground level ozone, and we talked about why ground level ozone is bad. It gets into your lungs, it causes respiratory problems. Here is just another diagram that the NOx and the VOx, you need that sunlight, and you get your ozone. All right, let's move on to smog. Now we have smog. Show how smog is formed, specifically industrial smog. So you want to start with your industry here. Okay, see if you can put together the reactants and how smog is formed. Pause the video if you need to. Here is the answer. All right, it's actually pretty simple. Smog is just particulate matter getting into the atmosphere and combining with water to form that kind of smog. Now, this is not droplets of water, this is moisture in the air. So this is droplets of water, tiny droplets of water, like you get when you get fog, right? You get fog. Fog is basically a cloud that's at ground level. When it's foggy out, you're basically inside of a cloud. There's little droplets of water. Sometimes you can even feel the little droplets of water condensing on your body. So that's what happens here. It's only that the particulate matter is what the water gas is condensing on. So the particulate matter that comes out of here is the condensation nuclei for the water droplet to form. And so you get a cloud, basically, except it's a cloud of pollutants. So that's bad. All right, let's see if we can get to photochemical smog. This is different. So you need to know the differences between industrial smog and photochemical smog. Different sources and different kind of cocktail, if you would, of things. So see if you can put the diagram together for this one. I will, you can pause the video and I'll come back. Okay, this is a little bigger one here because photochemical smog is a real nice cocktail of different things. You got your NOx and your VOx, and in the presence of sunlight you get ozone. So this is our ozone formation, which we covered in an earlier slide. So you have your ozone now, and now you combine your ozone with your particulate matter, and that's where you get your photochemical smog. All right, so it's the ozone here, and of course needs to be in the presence of sunlight. That's critical to remember. We're coming up on 15 minutes. Wow, that was fast. We're going to have to do a third video because we got quite a few things to get through, but I think 15 minutes will do us. So thanks for this one. We'll see you on video 3.